All right, you guys, so we've been talking about the standard normal distribution. So remember, this standard normal distribution has a mean of 0 and a standard deviation of 1. So now in chapter 5.2, we're going to look at finding probabilities of any old normal distribution. All right, so if a random variable x is normally distributed, you can find the probability that x will fall in a given interval by calculating the area under the normal curve for that interval. All right, this is math jargon. All right, so what we need to get familiar with in this lecture is the notation of how I can ask you for an area or probability. All right, and how we can use Excel to find that. Okay, so notice we're changing our notation a little bit. All right, so you guys need to be able to see this symbol. All right, so we have a capital P, and then in parentheses it reads x less than 600. What you need to be able to do is read the English of those symbols. All right, so what I've circled in red would be read as the probability that x is less than 600. Okay, given a mean of 500 and a standard deviation of 100. Okay. So in a plain old normal distribution, we're going to be able to use Excel to calculate this probability. Remember, probabilities are always to the left of the random variable that we're interested in. All right. So here, in a plain old normal distribution, we have mu is 500, our standard deviation is 100, and we're interested again in the probability that x is less than 600. We can convert this to a standard normal distribution using our z-score formula. All right, so we can take 600 minus 500, so our x, our random variable 600, minus the mean 500. Divide that by the standard deviation of 100, and we get 1. All right, so just as on the left, where we're trying to get the probability that x is less than 600, in a standard normal distribution, it's equivalent to trying to find the probability that z is less than 1. And you can use either one of these. Now, hopefully you're listening to me, you guys are awake, all right? When I say that when you use Excel, you really don't need to do this. This is when we used to have to convert normal distributions to standard normal distributions because we used to be stuck to looking at those standard normal tables. Okay, we're not stuck with that anymore. We have the beauty of Excel. And with Excel, you don't have to do this conversion. All right, you just need to know that if I ask you for a probability with a normal distribution versus a standard normal distribution, that our formula in Excel is a little bit different. Okay, so let's go through a couple of examples here. A survey indicates that people use their cellular phones on average of 1.5 years before buying a new one. This is not always true. I happen to go through 3 in the month of June. The standard deviation is 0.25 years. A cellular phone user is selected at random. Find the probability that the user will use their current phone for less than 1 year before buying a new one. Assume that the variable x is normally distributed. All right. I have to tell you this somewhere in the problem, that our random variable is normally distributed, okay? Once I do, all right, we can use Excel. All right, so I'm going to make this smaller. All right, now I'm going to go over here to Excel. All right, I gotta be given a mean, I have to be given a standard deviation, and I have to be given a random variable. Okay, and I should say, you know, this is going to be our x. All right, let's look at this problem. What is our mean, guys? Our mean is 1.5 years. Our standard deviation is a quarter of a year. And we are interested in finding the probability that the user will use their current phone less than 1 year. And I'm going to say one is our random variable, and we want less than. Okay? So our probability, we are going to use, now remember in the first lecture we used something called and I'm going to type it up here for you guys, norm.s.dist. Okay, that's what we used where we would input a z-score and the word true. All right, now we don't have a standard normal. That's what that S stands for. So now we're going to use norm.dist, and our inputs are x, comma, mu, I'm going to say mean, comma, standard dev, comma, true. Okay? So, and remember, it's always going to give us the probability of less than. So we check that we want less than 1 year. So there's no other math I need to do. I simply need to do equals norm.dist. All right, my random variable is 1. My mean is 1.5. My standard deviation is 1/4. And I always got to say true. All right. And so there we see that less than 2%, okay? So there's a 2% chance that somebody picked at random uses their phone for less than a year. All right? And there we can see the difference in between the normal and standard normal. Let's go ahead and do a standard normal conversion like I've done here in the slide. All right, so let's get a z-score. All right, z-score is our 1 minus our mean, close parentheses, divided by our standard deviation. All right, minus 2. All right, now let's get our probability. All right, and this is equals, now we're doing standard normal, so norm.s.dist of -2, comma, true. And you can see that our probability is identical. Okay, so 2 options to get the same answer. This is obviously much easier using just the plain old normal distribution function, okay, because there was no math to do. We didn't have to do the z-score conversion. All right, let's do another example. All right, a survey indicates that for each trip to the supermarket, a shopper spends on average of 45 minutes with a standard deviation of 12 minutes in the store. I don't think I've ever spent 45 minutes in a store. All right, the length of time spent in the store is normally distributed and is represented by the variable x. Okay, so there's our clue that we're dealing with something normally distributed. A shopper enters the store. All right, we have this little old lady. She enters Walmart. Find the probability that the shopper will be in the store for between 24 and 54 minutes. Okay, so I come over here and I've got to be given a mean, I've got to be given a standard deviation, and I've got to be given our random variable x. All right, let's look back through our word problem here. We see that on average people spend 45 minutes with a standard deviation of 12 minutes. And now, aha, I have 2 x's. All right, because now I want to know between 24 and 54 minutes. All right, so let's see here. You guys, I am trying to merge these cells. All right, and I'm going to type between. Okay, so we want to know between 24 and 54 minutes. So how are we going to do that? All right, well, again, we are going to use our norm.dist formula. Okay, so we've got equals norm.dist. All right, now we want the area between these two. All right, so how are we going to calculate that? Well, we always start with the largest number. All right, so we're going to get the area or the probability to the left of 54 first. All right, so 54, mean of 45, standard deviation of 12, and I always type true. Okay, and we don't want the entire area to the left of 54. We want to stop at 24. So we need to subtract the area to the left of 24. So this is where we do norm.dist of our larger number, the 54, and now we're going to subtract norm.dist, all right, the probability or area to the left of 24. All right, so I have my inputs of 24 is my x, 45 is my mean, 12 is my standard deviation, and like always I type true. And there we have our probability that if we were to pick a shopper at random, all right, or this little old lady, there's a 73% chance that this little old lady is going to spend between 24 and 54 minutes in the store. Okay, and we can see here, all right, with the actual math, and you guys can see in the blue shaded regions what we've done. All right, so we got the area to the left of the entire left of 54, and we subtracted the area to the left of 24. Okay, we can convert to z-scores. There's really no reason. If we were to convert to z-scores, all right, so let's get a z-score. I'm going to say z-score for 54 and a z-score for 24. All right, so here we have equals, all right, 54 minus 45, close my parentheses, divided by my standard deviation. All right, that's our 0.75 that we see here in the slide. And now let's get a z-score for 24, so x minus my mean, close parentheses, divided by my standard deviation. And there's my negative 1.75. And if we want the probability between 54 and 24, all right, using my z-scores, we'll have equals norm.s.dist. Remember, we've got to use the .s now because we have z-scores. We start with our largest one of 0.75, comma true, minus norm.s.dist of negative 1.75, comma true. So here we should see, once I press enter, that we get 73%, and indeed we do. Okay, because using the normal distribution function and the standard normal distribution function, they're identical. It's just a matter of whether we convert to z-scores or not. All right, so let's consider this question. If 200 shoppers enter the store, how many shoppers would you expect to be in the store between 24 and 54 minutes? All right, well, we just figured out right here, let me go ahead and highlight it for you, that the probability a shopper spends between 24 and 54 minutes in a store is 73%. All right, so what if I have 200 shoppers? Well, then how many shoppers? Well, all we need to do, guys, is take 200 times our probability. All right, and so this is just going to be equals 200 times our percent, and we get 146.662698 shoppers. All right? Well, can we have 0.6 of a person? And hopefully you all are rolling your eyes going, heck no, Angie, we can't have 0.6 of a person. All right? So we got to round up. All right? And we can round up and say, well, we need 147. 147 shoppers would spend between 24 and 54 minutes. All right, and the function in Excel to round up is going to be ceiling. And I'm going to grab my number, comma, 1. All right, and if you are working on a PC, the function is ceiling.math instead of just plain old ceiling like I'm using with the Mac. All right, but I can work with you on that if you have a question. All right, so we've got our 147 shoppers spend between 24 and 54 minutes in the store. All right. Find the probability that the shopper will be in the store more than 39 minutes. All right, so I'm going to move this down. All right, so now we want x of 39, and we want more than. Okay, So now what are we going to do? Well, now, all right, we're going to do equals. All right, if I start typing norm.dist, all right, remember I'm going to get the area to the left, and we can go ahead and I'll go ahead and move to the next slide so you guys can see it as I talk through it. All right, so if I were to just get the probability, then I'm going to get the area to the left. I want more than 39. I want the area to the right. So see how I've shaded the light blue to the right. All right, so this is where, hopefully you remember from the first lecture, this is where we have to do our entire area, 1, minus the area to the left. All right, so I take the whole area, I subtract the area to the left, and I'll get the area to the right. So 1 minus norm dot dist, and my x now is 39, my mean is still 45, my standard deviation is still 12 minutes, and I always have to type true. Okay, and we see that, all right, the probability is 69% that a shopper spends more than 39 minutes in the store. All right, so again, this is 1 minus norm dot dist of x comma mean comma standard deviation comma true. And I will highlight that probability for you. So again, when we want more than, it's 1 minus the probability to the left. All right, can we do a z-score? Sure we can. All right, first we need a z-score for 39. All right, so we do equals, all right, 39 minus the mean of 45 divided by the standard deviation of 12. All right, so we get a z-score of negative 0.5. Now we want the probability more than 39. So what do? We say equals 1 minus, not more, but norm dot s dot dist, all right, because now we're using the standard normal of negative 0.5, comma true, and you can see we get the exact same answer we did up here using the normal distribution function, okay? All right, if 200 shoppers enter the store, how many shoppers would you expect to be in the store more than 39 minutes? Well, again, we need to take 200 times our probability that we found, all right? And so we have equals our 200 shoppers, and 69% of them are going to spend more than 39 minutes in the store. And so we can see that 138.292 is our exact answer, but again, we can't have 0.29 of a person, so we round this up. And again, I'm using equal ceiling of my 138. All right, and I end up with, interesting, I say round up, and your book is saying round down. Honestly, you typically want to round up, and it has to do more, and I come from more of a business background, but I would accept either answer here. If you want to round that down to 138, that's fine, but again, we typically always round up, okay? And again, that has more to do with money in business. But again, all right, so here 138 or 139 shoppers will spend more than 39 minutes in the store, right? And I'm just going to go ahead and change this because I really firmly believe we round up. Okay, let's do one more. Hopefully some of you recognize the picture that I put on this slide. You'll see that's Miley Cyrus. All right, triglycerides are a type of fat in the bloodstream. The mean triglyceride level in the United States is 134 milligrams per deciliter. All right, so here's a good old nursing example. Assume the triglyceride levels of the population of the U.S. are normally distributed with a standard deviation of 35 milligrams per deciliter. You randomly select a person from the U.S. We randomly select Miley Cyrus. What is the probability that the person's triglyceride level is less than 80? Okay, so again, we've got to have a mean, we've got to have a standard deviation, and we've got to have an x. All right, our mean is 134 milligrams per deciliter. Our standard deviation is 35. All right, and our x is 80, and what do we want, guys? We want less than 80. All right, so this isn't too bad. This is just going to be our plain old function here. All right, we just need to do equal since we want the area less than or to the left. We're just going to do norm dot dist, all right, of my x 80, then my mean 134, all right, then my standard deviation, and then true. And you can see that, all right, if we pick someone at random, all right, there's a probability that the person's triglyceride level, the probability is 6% that the person's triglyceride level is less than 80. Okay, so it's important to be able to interpret these numbers. All right, so you can see that we're calculating them very, very quickly. All right, but what's it mean? All right, it means that if we were to just walk across campus and randomly pick somebody, that we have a 6% chance that that person has a triglyceride level of less than 80 milligrams per deciliter. Okay, can we do a z-score? Sure we can. Let's go ahead and do that very quickly here. Z-score for, let's see, 80. All right, so we do equals, in parentheses, our 80 minus our mean, close parentheses, divided by our standard deviation. So we get our z-score. And now we want our norm dot s dot dist of our z. Okay, so he equals norm dot s dot dist, all right, of our z, true, and you can see that we get the exact same answer. And notice I did use a cell reference there in the function, which you certainly can do. All right, so again, whether we use the standard normal or a regular normal distribution, we get that if we randomly pick somebody in the U.S., that we have a 6% chance that that person has a triglyceride level of less than 80. All right?